DataSandbox is a two-dimensional, hands-on simulation platform for statistical sense-making. Instead of 3D immersion, it asks a simple question. What if you could grab a statistic and feel it move? Statistics is taught through formulas and static visualizations. Students reach the right numbers while holding fragile mental models. Most interactive tools cast learners as observers, where interaction is reduced to nudging a single parameter. What is missing is action. Tools emphasize inspection over manipulation. Immersive learning favors spatial presence, poorly aligned with abstract quantities. And when AI explanation is detached from action, it invites passive answer-seeking. Our move is interaction-centered immersion, sustained engagement with statistical relationships rather than spatial realism. Learners act on representations, observe immediate consequences, and revise their reasoning through iterative hypothesis testing. DataSandbox is built in 4 parts: a React and D3 front-end with hybrid rendering for interactive graphics, Dr. Gem, an AI coach grounded in each simulation's current mathematical state, dual instrumentation capturing clicks and semantic events, and a 10-block statistics curriculum. Concepts become objects you can grab. The dartboard makes variability perceptible through the spread of shots. The tail stretcher shows how confidence intervals shift with sample size. And the God mode switch lets learners feel the difference between observational and experimental studies. Feedback stays tightly coupled to action. Real-time cues make every consequence perceptible. The AI coach explains the current mathematical state without prescribing the answer. And research-ready logging captures both low-level traces and semantic events. Instrumentation as insight, not surveillance. In a pilot showcase, 15 introductory statistics undergraduates explored the modules. Interaction heat maps revealed active inquiry across the interface, and module trajectories showed a shared search and refine rhythm. Exploratory spikes followed by stabilization. These data illustrate logging feasibility, not learning outcomes. Our contribution extends immersion into abstract representational domains, where action, not navigation, is the immersive mechanism. AI serves as a formative mediator that preserves agency, and instrumentation treats interaction sequences as epistemic evidence of thinking. Where does this go next? Linking manipulation patterns to conceptual change and aligning AI support with each learner's interaction history. Try the live system and join us in designing immersion for the abstract.